So, hello everybody. I am Cédric Bélanger from Marketing Communication Department at OPTIS. And today I'm very pleased to co-present with Julien Muller, OPTIS Product Manager of Solutions for Automotive. We present our latest solutions for automotive exterior lighting, the new generation of exterior lighting in automotive. First, a few words about OPTIS. OPTIS is a world-leading company in virtual prototyping, provides simulation software allowing you to accurately simulate the performances of light, human vision, and material interaction, ultimately allowing you to experience your product virtually before ever spending the time and money to build multiple physical prototypes. So thanks to OPTIS, you can imagine, design, and virtually see and hear what you will get during all stages of the design, engineering, and manufacturing process. The summary, I will start with the trends and challenges, then Julien will develop the solutions with a live demo. I will finish on our vision about virtual prototyping. Let's start with the trends and challenges. Night driving is an important stress factor. In a recent American driving survey, to the question, what is the main stressful factor for you on the road, still 50% of the drivers mentioned that the first and most stressful factor is the poor lighting at night. So intelligent, innovative exterior lighting systems need to bring comfort at night. Exterior lighting have to answer to the huge safety issue that night driving still represent nowadays. National Highway Traffic Safety Administration reports that only 20% of driving distances is undertaken at night, representing 2.4% of the traffic volume. But in this period, 40% of fatal and serious injuries are sustained by drivers. It's 4 of every 10 teen crash deaths that occur at night. Actually, the nighttime is a safety issue for all road users, especially the vulnerable road users, a heterogeneous group of pedestrians, cyclists, younger and elder, and disabled people. European studies have highlighted the strong effect of lighting levels on fatal crashes of vulnerable road users, being 3 to 7 times more vulnerable in the dark than in the daylight. So innovative automotive lighting need to improve the safety of these vulnerable by communicating, by alerting, warning with lights. Finally, exterior lighting represents also an aesthetic challenge. Exterior lighting reflects today the brand signature and a major impact on the customer perception, estimated to represent by itself 25% of the style of a vehicle. This is the new competition arena for car manufacturers and tier 1 suppliers. The competition is on shapes, on materials, light technologies, and their performances. The engineering development time is doubled at each headlamp generation. I will now let Julien, the manager of Automotive Exterior Lighting, go deeper into our solution to address all these challenges.
So hello everyone. So today I will present you the pixel beam technology and evolutions, but first I will start with a brief overview about the last decade to look a little bit about the latest evolution in automotive lighting. So first I would say 10 years ago, or maybe even longer, with the first Citroën DS. It was the first AFS with a low beam turning with a steering wheel. So this is always not a standard feature for all the cars, so it's still proposed as an option on the high-range cars, but this allows a big improvement for the safety of the driver. So the idea is to add some light in the curve by using the steering wheel or the speed. Another solution could be also to add light depending on the condition, depending if you are driving on a motorway or during the if it is raining. You can adapt the lighting to have a better driving situation. And ultimately, actually, you can have an automatic driving beam, so we call it ADB. So the idea is to use the camera to control your lighting system. And at that time, with that technology, I would say, by using xenon or even LEDs, you have an L shape creating a dynamic shadow at the center to avoid to glare the oncoming driver or the preceding cars. So basically, this is all these three solutions, I would say, is quite mature technology. It's based on mechanical movement, but it allows really an automatic driving, so really to drive safely during the night. Recently, we have seen the matrix beam is coming thanks to LEDs, so you can add light even between the cars. So some pixels can be lit even between the cars, so you can put a lot of light everywhere. But you can still see some shadow on the road, so some light are still missing. Sometimes you need to switch some pixels, whereas you want to put some lights in between or around the car, near the car, something like this. So now we need to consider the ADB based on pixel beam. So either with DMD, but a solution using LCD is also relevant for that. So the idea is to increase the number of pixels. So instead of, we say, hundreds LEDs, now we can consider hundreds, thousands of pixels, or even millions of pixels. So this is, I would say, the HD or retina lighting for automotive lighting. And another technology also which is considered for the future or under development is to use MEMS. So MEMS is a mechanical scanning mirror. It's really a small micro mirror using a laser source. And the idea is really to control the scanning mirror to print an image rather on the phosphor or directly on the road with a RGB laser source. We'll see that later in the next video. So the idea of this technology is to create a picture beam, so you can project any images on the road, so you can really adapt your lighting to the road condition. So definitely the future lighting will be digital and intelligent. Here just a brief overview of the Audi e-tron concept, the Sportback 2017 concept, with some technologies showing. This is quite interesting for understanding the technology by combining LEDs and laser. So you can see that the matrix laser is used here. So it's based on a MEMS, and this is quite useful to have the car-to-car communication or car-to-pedestrian communication to show some warning information. If we are now going back to the headlights, we can see that that technology allows to display whatever you want. So that's why we call it sometimes a picture beam, because any pictures can be shown on the road. So you can have a precise dimming, you can project some lines, you can create some shadows, etc. So the other video I want to show you, which is coming from Mercedes in that case, it's a digital light concept. It's more practical use cases. They can show some crosswalk, some road signs. They can also display some lanes to control the car in some dangerous situation. Navigation information could be also useful. Road signs again, and even a smiley can be presented. If we are more looking to the top view on a realistic road, we can see how does it work. And if you consider a rider, we can have a precise glare-free solution to avoid to glare the oncoming driver or rider, but we still put some light on him to be sure that we detect her, by the way. And another application we have seen on that video is a crosswalk. So you can imagine in case of autonomous driving, you want to have a communication to the pedestrian. Okay, I've seen you, I have detected you, you can cross safely. And the way to display that message is to print a crosswalk just in front of him, and he understands that he can cross safely. So our solution for these use cases will be based on VRX. So VRX is a standard platform we have developed for the virtual reality. So the idea is to have just one single drive simulator. This simulator is dedicated to the headlamp simulator for headlamps, ADB, matrix beam, or pixel beam. So we'll discuss that later. This platform is also used for sensor simulation with software in the loop, model in the loop, hardware in the loop simulation of different sensors like camera, LiDAR, or ultrasonic. And this platform is also used for 3D immersive simulation, for ergonomics application, for HMI evaluation studies to understand how the driver is reacting depending of the information you are displaying to him. So today we mainly focus on the headlamp simulator because this is our focus for exterior lighting. So what you have to keep in mind is first you need to define a track and a scenario. This is the first step. You need to define a specific trajectory of your car, a specific how can I say, geometry of the roads, depending if you have some turns, if you have some mountains, if you're in the countryside, and some scenario. Do you have some pedestrians? Do you have some cars which are coming, which you are following? So thanks to that, to achieve that, we have built a partnership with OPTIS. So we are using the software, which is well known on the market to build some scenarios and some roads. So here it's an example of a roundabout. So this is a track, and we can put some cars on this roundabouts, and they are controlled by scanner. So scanner is controlling the track and the car position, and inside the software, so here it is VRX, we can display, we can show the rendering by using our physics-based rendering. Here it is during the day, but of course our focus will be more during the night. So we'll have a complex scenario during the night with an advanced vehicle dynamic simulation. And we can have some scripting of the different scenarios which are appearing during the night, so you can control the position of the cars when it's starting, when it's braking, any complex scenario. So that's the solution for the scenario. And now we can focus on the object detection with the camera, the image processing thanks to the AFLS or ECU of the car body to control the headlamps. So to control the headlamps could be either to control the driver, the LED driver, to control the dimming of the LEDs, the power output of the LEDs, or to control the MEMS or DMD output. So first, I want to remind you that VRX can be used for the matrix beam, the conventional matrix beam, I would say, which is the right solution if you want to have from between 4 or 200 pixels on the road, so meaning 4 to 200 LEDs. On your board. So in that case, here we have an example of a scenario. So we are driving, we are just crossed the car, we are preceding a car preceding us, and you can see in the top, we can see that there is a graph. This graphic is showing you the percentage of light we are putting on the road. So this graphic is adapting in real time because behind there is a real-time simulation to control the headlamps. So this is in combination with MATLAB Simulink. So you can do the model in the loop evaluation. So you can change your parameters. You can evaluate the impact of your parameters on this performance, on the quantity of light you are putting on the road. You can also evaluate the glare generating on the oncoming drivers or the following cars. So you can adapt your parameters to have the best compromise between safety and comfort for the driver. I will present that later in the live demo, but just first introduction for you. And the next technology which is coming is a pixel beam. So pixel beam is really between 1,000 and 2 million LEDs, but LED is not a good solution here, so pixels. And the only way to achieve that is, as I just say, not LEDs, but GMD, or even LCD could be a good solution. But MEMS as well can be simulated thanks to our technology. So here it is just a short video to explain you how does it work. So we are following some cars. This is the same scenario than before, but you can see that in real time we are creating some shadow around the objects we are following which are coming in front of us. So here you can see that the motorcycle or the car which are coming in front of us are tracked, recognized by the camera, and we are creating a shadow just in front of them. So this is just a first idea of what we can do, but I want to show you a live demo. How does it work? So I will switch to VRX, which is our software for virtual driving. So this simulation here contains 2 cars, and the idea is to control this car behavior with a MATLAB Simulink model. So this is a MATLAB Simulink model I will use for that demo. So the headlamps is controlled through that block. So I can control the activation of low beam, high beam, and I can activate different intelligent lighting functions. So you will see that later. And then I have different parameters to control the camera. So camera position or field of view. I can control the bending light position, the max angles. For matrix beam, I can control the dimming up. So you can see this curve. This is the percentage of the dimming up in time. So I can add more steps to have something smoother. You can see the curve here is automatically updated, and it will be the same in VRX. We'll see that. And of course, I have the possibility to have a pixel beam. And in the case of pixel beam, the key point is the field of view of the pixel beam and the resolution. So I will just hide this model and to show you in live how does it work. So in this situation, we are in high beam. So of course, we are glaring the preceding car. So the best way in that condition will be to be in low beam. In that situation, I have put a aiming wall just to show the beam pattern and to understand how does it work. So now, if I activate the ADB, so the matrix beam, with the Simulink model, you can see that I'm adding some light. So if I'm driving, I can see that some light is adding around the car. I will just press a pause here. You can see that this car is now glared by my matrix beam. So this is because it is glared actually by the low beam. So if I'm switching back to low beam, the car you can see is glared by my low beam. So we have implemented an adaptive cutoff algorithm to adapt the cutoff position depending of the car position. So I will start again the demonstration with the ADB activated in high beam, and you can see that the low beam actually is adapting to the car position vertically. So in that case, you are putting some light just at the right position of the car. And finally, the last point I want to show you is, of course, the pixel beam. So you can see that in that case, the light is put everywhere except on the car. So again, I will switch between the matrix beam with cutoff adjustment and with the matrix beam. And with matrix beam, you can see that you are putting some light everywhere except on the car. So this is quite fantastic technology. And of course, it's working in real time. You can see that the trajectory of the pixel beam is adapting in real time. Here, this is the MATLAB Simulink result. So you can see that this square is running, adapting in real time to adapt to the car position. So that's just a brief overview about the model. Another point also maybe we can play with is the strategy of the dimming up. So this is what I was saying before. If we are changing that to only 5 steps, I will start again that demo. You will see that it will be more patchwork of light. So this is what you can see here. There is a patchwork of light. So this can be disturbing for the driver. So the idea is to add more steps. So yeah, for example, I'm putting 100 steps. In that case, you will see that it's smoother. So the switch on and off of the light will be smoother. So that's the VRX simulation. Maybe you are wondering how does it work for the optical definition of that. So how to create a shadow of that. So in that case, we need to use PEOS simulation. So this is PEOS integrated in CATIA, and this is I would say a simple imaging system using a DMD. So this is a lighting source which is collimated, and the lighting source actually is reflecting into that prism, arriving here to the MEMS. So this is a MEMS with a lot of micro mirrors. We will focus on that later. And then the light is reflecting into that compensation prism, and finally it's projecting through the lens. So just to explain you with some ray tracing, basically this is how does it work. So there is some reflections here, and for the pixels which are off, actually they are going out of the definition. So I will just hide that. I will hide also the prism just to focus closely to the MEMS to explain you how does it work. Yep. So that's the MEMS status. So I have just show a brief just some pixels of the MEMS. So the MEMS here, it's composed of 1 million mirrors, but here I'm just looking at a few of them. Oops, sorry. So you can see that in that case, only this square is switched on. And the key point is I can control this situation just by using a small MATLAB script. So the idea is again to adapt the configuration of your DMD in Speos based on the Speos simulation. So in that case, here I can change, I will just run the MATLAB simulating update. So you will see that I will generate another configuration of my pixel. Oh, sorry, of my pixels. So now you can see that all the micro mirrors are slightly shifted in another direction. Again, just to have a closer look, closer eye. And of course, we can run a Speos simulation to have the result of that. And I will show you that. Just wait for the update. Yeah. Now it's updating the graphics. So yeah, you can see that in this configuration, we are just creating one shadow on the square. So if we are looking at the result, the first result was just a quarter, which is switch off. And you can see, thanks to Speos, the colorimetric aberration. By using the other definition, in that case, after the Speos simulation, we just observe that this is just V square. So the key point is you can use Speos to have the precise simulation. So thanks to Speos, you can simulate the colorimetric aberration you can see here. So maybe you expect to have really a dark area, but thanks to Speos, you can see that this is not really dark because you will have some colorimetric aberration, and you have also some distortion. So the message here is Speos need to be used by the optical engineer to design the optical concept to achieve the best quality of the light, whereas VRIX is used for the system engineer. So the system engineer can evaluate anything, any ID actually, for the picture beam, for example. So any ID can be experienced in real time. We have seen today just a short demo, but ADB with smooth edges can be represented, lane marking, navigation information, as we have seen before, signature projection. You can project your logo, you can project some innovative welcome light, something like this when you arrive at home or something like this. And of course, movie projection can be presented as well. Maybe not like this, but Mickey can be presented on the screen. So this is just a proof of concept to explain you what we can do with VRIX. So this is running in real time, so you can test in real time your ID. So as a business benefits, our innovation can be tested. It can be tested in the early demonstration, so really some months before the first prototype. You can play with the simulation, with the model to find the right parameter. You can define your brand images, so to find the best way to sell your car or your project. And of course, we have also some rating and reports available inside our software. Regarding the financial impact, as we are reducing the number of physical prototypes and also the number of testing, you can save some time and money thanks to our solution. And finally, for engineers and for managers to understand how does it work, we are based on a physical rendering engine, physical-based rendering engine. So it's something you can trust. It's close to reality. We have done some certification of our Speos solution, so you can trust the result. We have some virtual tools to assess the light and the glare, for example. IHS rating is another topic, but we are supporting that. Of course, all the adaptive I-beam can be supported as we have seen today, so any complex MATLAB Simulink model can be tested in real time in our solution. Thanks to our partnership, I will say our co-simulation with other platforms, complex scenario can be evaluated, and we are delivering already some libraries of scenario to test your things. So that's our solution, and I will give back the mic to Cedric.
Thank you, Julien, for this very interesting demonstration. Live demo is always appreciated. Yeah, so just to, I wanted to finish off on our vision. What we do is we enable our partners in delivering innovative designs that have been tested and optimized for their final customers. We assist our partners in many aspects of the design and engineering process, including safety, ergonomics, and perceived quality. This translates to several topics: color and material choice and uniformity, human-machine interface development, interior lighting, intelligent exterior lighting, as we have seen with Julien, and the current hot topics of HUD and globally ADAS and advanced driver assistance system and autonomous driving. The OPTIS proposal is a powerful collaborative design platform. Boost your creativity on CAD or mesh data. Imagine and test any materials, any colors, any lighting scenario in usage context under realistic exterior lighting conditions. Then engineer your creation. Take advantage of CAD PLM integrated and dedicated tools to design the lighting systems, from the light guides to matrix beam or pixel beam, using LED source from the market or MEMS from the market. Share with your business partners while keeping IP totally secure. And finally, take advantage of scientific but easy to use analysis tools to check the compliance with the regulations. With the OPTIS virtual prototyping solutions, you certify your system in virtual, saving you time and money. The key difference of OPTIS proposal is that our powerful design platform offers a tangible decision making solution. Don't wait until it's too late for the surprise of a bad consumer reports or JD Power ratings. In 2016, almost every auto manufacturer has failed exterior lighting tests in North America. Even the performances of Audi and BMW are not so bright. So with OPTIS, you create a virtual prototype, and in the beginning, you share a scale 1 through to life experience in virtual reality with the decision makers, with your customers. First, you improve the collaboration, the concurrent engineering among the different teams internally and among the business partners, OEMs with suppliers. Secondly, listen to the voice of the customers. From the early concept phase and throughout the development, focus on the perceived value of your innovation. Bring the value where it is most appreciated by the targeted consumer. Let's focus quickly on the virtual testing, because this is key in our solution, and it's very promising. It's a must-have for ADAS and new generation headlamp system developers. So first, the environment, we have pins that it is critical. Environment, weather, lighting conditions are perfectly reproduced, as well as the roads, the markings, the other vehicles and pedestrians. Diverse traffic lights can also be reproduced. Then the two workflows, the vehicle HMI and embedded intelligence sensor system, are simulated using physics-based modeling. We will simulate the HMI as the system and the sensor vision. With ADAS and all the advanced driver assistance systems and innovative headlamp system, there is now a shared control between the driver and automation, a cohabitation between two workflows. So the OPTIS Automotive Virtual Solution Platform is putting together the driver, the vehicle, and the environment in a lifelike experience, as the simulations are physics-based. And that's the really key of our proposal. So OPTIS, as you can see, has a very global, worldwide presence for local understanding. So I invite you to contact your local dealer and ask for an evaluation. I wish you a brilliant day. We stay connected if there are any questions. Thank you very much. Have a brilliant day. Bye-bye.